Hey guys, and welcome back to Aid's Workshop. Okay, so we're going to get on with doing the electrical side of setting up this stepper motor. So there are lots of bits and pieces, and I'm going to try and show you how I've wired it up. Now, the way I've wired it up is not necessarily the way it should be done, but it's the same procedure I've used on the milling machine for the two axes that I've powered up with stepper motors on the milling machine, and they seem to work perfectly well. Saying that, as long as I don't start them on full acceleration, where they tend to lock out a bit. If I start them on a slower speed and ramp them up, then I don't get a great problem. That's something I'm going to look at. I've already tried the motor for the lathe feed setup, and because it doesn't run at such high speeds, the lead screw for feeds and what have you, I've found that it works perfectly well without any locking out, even changing direction, max speed one to the other, that sort of thing. And I've tried it under load as well. So this is the way I've done it. It's not necessarily the correct way. Okay, so moving forward, a few bits of material, 500mm length of, oh, I don't think I recall what that is. I think it's 20mm square. In a video going forward, we're going to be making some T-nuts. We're going to be making some N8 T-nuts that fit the table of my mill. Typically, T-nuts are the correct size, are M10. But that, you know, if I buy a piece of 20mm square, most of the work is done for me, and we'll make basically a big long T-nut, drill and tap it, and chop it up afterwards. It makes it much quicker to make. And the other thing I've got, oh gosh, is a big chunk of steel here. Yeah, it's probably 15 kilos. I forgot to mention both of these are EN8, which is sort of, you know, it's a grade up from mild steel. It's a bit tougher and what have you. And we're going to be making some more tool holders for the lathe, you know, with the dovetail and what have you. And I bought it. The section I bought it in will allow me to do one long dovetail in a long piece and then chop it up to make the individual parts. It's always the dovetail that takes the longest. And once you've got it right once, you'll have it right for 4 or 5 different tool posts. So that's why I bought that particular section. It's about 1.5 inches by 2.5, I think it is. So yeah, quite a chunk of steel. I think that's 500mm long as well. A few other new bits and bobs in the shop. I'm not going to show those at present. But it involves a few upgrades for filming and my sound and what have you. Basically, I've bought myself a Christmas present. We'll go into that a little later. So I'll show you where I am with the enclosure now, and I'll do a bit of a talk over as far as I've got so far and try and show the components and bits and bobs we've got to make this electric stepper motor work. So yeah, as you can see, I've made a bit of a head start, but I am going to explain as best I can what we've got. I would if I could find a 12-inch rule. Where have I hidden that? Well, it always lives on the wall there. I don't know where it's gone. Where have I hidden it? There it is. Losing the plot, guys. Right, so this box is 200 by 200. Plastic enclosure, basically. Cheapest one I could find. I know it's got these big rubber grommets in it, but that's purely cosmetic. It doesn't matter. Depth of the box there is 50, and I think it's about 25 there. So I get about 75mm of depth on the box, but it's enough room for me to fit everything I need inside. And as you can see here, this is pretty much all the components. So I'm going to show you the wiring first of all. So I've got a little power supply here. It's the same power supply that I've raided out of the old feed motor, or the old sort of setup. It is a completely different setup, not being a stepper motor on the previous one. But it's a 24 volt power supply and it's 4 amp. Okay, it's important that I know I've got 4 amps at 24 volt to play with. So 230 live is going to come in this end, or 240 live. We're going to look at the 24 volt outlet. So there's 2 components now that need 24 volts, the outlet from this power supply. One is the stepper driver and the other one is the pulse generator here. So basically I've used yellow to represent 24 volt positive and white to represent negative. So you can see there's the outputs there. Left one is the negative, right is the positive, and you can see the plus on the board there, and there's a negative on the other side. So those wires run around the bottom, across here and up onto the stepper motor. So let's zoom in on that bit. Why did I call it a stepper motor? It's a stepper driver. Okay, so I got these little twin barreled what do they call them, bootlace terminals that crimp on. You get like a little, let me show you, It's a bit rusty, but it works perfectly well. You basically stick them in the crimp, and when you close the crimp, it crimps them up to the right tension on the wire. So you can get 2 wires into one terminal. So as you can see, the white comes around here, and it goes into the ground terminal. And I've bounced it on, and it heads off to the power supply. So I'll show you that in a moment. And exactly the same, the 24 volt positive comes in here on this one, volt positive, and bounces out, basically continues on to the pulse generator. So we'll go to the pulse generator. So I will put a link going forward, maybe in this video or a next one along, to the stepper driver that we just looked at. It's a DM524T, and it was from Steppers Online. I believe the little pulse generator here was an eBay purchase, but I'll send a link to that as well. So as you can see, the 24 negative also supplies this terminal here. It's the there's basically a terminal with or a contact block at the back here with 6 terminals on, and this one only has 2. So it's basically negative in this one, closest to the big heatsink, and positive 24 volt into the furthest one, further away from the heatsink. Okay. So what's next? You can see I've got 2 switches in here. They're basically toggle switches. Let me see if I think I've got a spare. Yes, I have. I've got a third one here. I'll show you the toggle switch. They're double pole, but they don't need to be. Single pole ones would do. So yeah, basically a little on-off toggle switch. Make or break, basically. So one direction, these 2 would be joined, and then the other direction, it breaks the circuit, and exactly the same for these 2. But you could make and break 2 separate circuits using one switch, because they're double poled. But yeah, that's basically the same. Both switches are the same. As you can see, I've fitted one in vertically. That's going to be my on-off switch. And I fit one, the other one is fitted in side to side in the lid of the box. So that's going to be my direction. And basically the toggle facing away from the chuck will be reversed on the lead screw, and towards the chuck will be forward. Just, you know, that's a visual thing. So that's the 24 volt lines. Okay, so we're going to look next at how the signal lines are going to work, how this pulse generator tells the stepper driver what to do, and how the switches are involved. So you can see here I've got these 4 wires already in, and I'll try and explain these. So starting at the back terminal, the one opposite where we brought the power in, the rear one is the pulse. So the pulse we've got in brown. The yellow there is the direction. So coming out of the direction, I've gone through my directional switch, which is this one. So I can break that direction wire coming out using this switch. Make or break is how it works. And then, so my direction wire is going to be yellow. The white one is my enable. So that runs out from the enable socket. And this is the third one from the back. Oh, I'm jiggling about on you. Which is the enable. That runs through my on-off switch. So again, I can make and break the circuit with the on-off switch. So my enable is the white cable here. I'm sorry I've used the same colours as I did for the 24 volt negative, but I've only got so many colours of wire in stock. And then the fourth one, the green one, let me recall. Yes, the green one is the negative or ground wire. So we'll show you where that goes in a second, but it's basically just 4 wires. So we've got a directional, an enable, a pulse, and a ground. So pulse is the brown at the back, direction yellow, enable is the white or on off, in this case what I'm using it for, and the green wire is the ground. So we'll go back now to the stepper motor, or keep saying that, stepper driver, and show you how it wires into there. Okay, so you see this negative, enable negative, that would be the ground wire, the green. But I also got a direction negative, so the green would go on there as well. And I've got a pulse negative, so the green would go on the pulse negative as well. So what I'm going to do is bring the green wire into here, and then bounce it on into this one and this one as well. So that's the green, the basically the ground, you know, the voltage ground from the pulse generator. So with my green wire, I'm going to route it now, but show you roughly how it works. So let me just put it in there temporarily, just to show you the wiring, and then obviously I'll neaten it all up afterwards. Try not to bang the camera, or the tripod at least. Oh, I can actually take the little socket off, so I'm going to do that. So I'm going to feed that in there. I am going to be putting some little bootlaces on the end of here, but this is purely for demonstration. So the green one goes onto there. So that basically is the enable ground. Now I don't want to run the 1, 2, 3 green wires all the way back to the other side. So all I'm going to do is bounce them on a wire from there to there and there to there. So I'll do that off camera and bring you back. Okay, so as you can see, the green ground wire comes onto terminal, we'll call it terminal 1, enabled minus, terminal 3, direction minus, and terminal 5, which is pulse minus. Okay, so that's where we are with that. Next thing we need to do is let's bring the pulse wire in, which was the brown one. So basically, I'm going to tidy all this up afterwards, but I'm leaving all these wires long. So the brown one that we described earlier on is the pulse. We'll notch it up, okay. So the pulse wire, as you would imagine, is going to go onto pulse positive. So it's going to go onto this terminal. So I'll show you that as we go forward. Then the next one we've got is the enable, which is the white as we described earlier. So the white one that we used, the enable, is going to go on enable plus, so the second terminal. And then finally the direction, which was the yellow one I showed you earlier, is going to go on direction plus. So I'm going to tidy all this wiring up, wire it all into place in these sockets, and I'll show you the finished article. So there we are. That's the negatives bounced on to pin 1, pin 3, the direction negative, and the pulse negative, pin 5 or 4, 5, yeah, okay, 5 up here. So I've got my pulse, which was the brown, onto the top terminal, the direction positive coming through my direction switch from the pulse generator onto direction positive, and the enable again coming through my off-on switch from the pulse generator onto the enable positive. Very simple. So that's the actual communication setup all done between the pulse generator and the stepper driver. So the next thing we need to do now is connect up the 4 wires from the stepper motor. So the stepper motor consists of 2 windings, A plus and minus, B plus and minus. And actually Stepper's Online, which is the firm I bought it from here, Stepper Online, supplied me with a little drawing which shows which colours on the motor are the different windings. So as you'd imagine, you can see here, I put the black in A positive, the green in A minus, the B positive would be red, and the B positive would be blue. Now, if you haven't got a chart, and maybe your wires aren't this colour, there's a way to see which winding or which wires, colours of wires coming out. I'll show you that. Extended the 4 wires from the motor to make them long enough for my purposes. So what we need to do, as you can see, with nothing touching each other, I can turn the stepper motor freely. If I ground out the 2 wires from one winding, so let's say I'm looking and I don't know which are a pair, so I join, for instance, red and green, no difference whatsoever. It's still free running. Okay, so hang on, red and green joined together and I can still turn the motor freely. So okay, let's try red and blue together. So I'll join those together. It's locking up now. I've shorted out that winding. So I know that blue and red are a pair, and that pretty much means, let's just double it up the other way. If I go black and green, the other pair, or what I think is the other pair, it doesn't matter what colour they are in your instance, but there's the black and green, free running on the motor, join them together, no power involved here, join the 2 together, and it's locked out. So I know that's the other pair. So it pretty much tells me in this case that my drawing was correct. So having done that little trick to see which 2 are A and which 2 are B, I don't know which 2 are A and B, but I know I've got the 2 pairs. It doesn't really matter. So if I was to put B positive and B negative in the first 2, whichever they are, it doesn't matter. And then again, I don't know which way's positive and which way's negative. Again, it doesn't matter. I didn't have any instructions on the first time I did it, and I had no idea why I did what, but what I could do is suss out which were pairs by doing the, the bind up on a motor check. But as long as I put a pair in A and in the 2 A's and a pair in the 2 B's, it doesn't seem to matter. I've tried it both ways, and it it still works fine. So it's possible that if you swap the two around, it may go in an opposite direction, or if you swap the two pairs, you know, the B plus and B minus, it might go in I haven't tried that, but either way, it doesn't really matter. It works. It'll drive the motor. So that's those four. So when I get this mounted and I get some holes and some glands in my box, I'll be able to run the wires from the motor into those four terminals, and obviously following the rule as the little sketch showed. Once I've connected all that up, the final thing, I'm going to run it on a switch supply on the wall, a 13 amp plug. I've got one very close by. I'll bring it in the right sort of spot in the box, wherever it works out when I put it on the wall. And obviously I've got my positive and negative connection. There's no earth on this board. On the there's no grounding earth on the power supply, so I'm not gonna be using an earth. But with this being in a proper insulated box, I'm not going to have any problems. It's basically double insulated, and the only output from this box is 24 volt DC. So that's obviously, if I had a 240 coming out, something like that, going somewhere else, then I'd probably put an earthing spike on here. I'd probably connect up to the chassis of this driver, may even drill and tap a hole in these heat sinks, but I would ground it all out. But for this operation, the 230 comes here and here only onto this card, so happy days. I don't need to do it. I think I will mount this through a gland of some sort coming into the box, so that it's got the strain on the cable, and I'll do something similar when I bring the four wires in from the motor. Okay, so a quick update on the Stewart model's engine. I made the replacement cap. I don't know whether I lost it or I only made 3 in the first place, but I made a spare, or made the one to go on. I've changed the fitting here, so I've now got a threaded fitting. Made a little decorative sort of chimney for the exhaust valve, or the exhaust port. It's all assembled. It runs like an absolute dream. Let me show you the pipe. So the pipe just screws on there. The air pipe from my little compressor. So that just screws on there. So I can, if I just got it in the right place, let me zoom out on this. We're getting a bit close. So I can actually blow, let me see if I can get half-inch shot and get the engine to run with the power of my lungs, which is not considerable. Yeah, I mean, it just runs so smoothly. You know, I can make it run purely by blowing into the pipe. I'll do it again. So there you are. Right, decorative finish on the plate now. So I plugged it all in on the bench, just gave it a whirl, and realised that there was no power coming in. The little LED here was not lighting up. And as it happened, I had this reverse polarityed. So yeah, the yellow wire here is 12 volt positive, which is closer to the heatsink, and the white one is the negative. I had these two wires the wrong way around, so just thought I'd share that in case somebody followed what I was doing step for step. So there we are. Yeah, it's well worth getting that right. Well, if you don't get it right, it doesn't work. But it didn't do any damage to anything. So the plate's been moved around, battered and bruised over the period of time that I've been working on it. I never did machine this space, it was the raw aluminium. So I'm just going to tidy up this space. The finish looks sweet. Probably slow that feed down a bit. That said, I think I've got it. Yep, I'm going to leave that alone. Hold on, let's just turn the lathe off. Okay, so we're all hooked up. Everything's running. I've got to put some holes in the top of the box at the back and a few in the bottom of the box on the backside, away from where any swamp's going to spray, just to let aid with cooling and let a bit of airflow across the box. But yeah, I mean, it's switched on, motor's running. I wonder if I can pan you out a bit. So if I just go to the panel here, turn it up as fast as I want it to go. I can't see me needing a feed rate any faster than that. Let me just bring the carriage back. As you can see, I can engage, disengage, on and off. That's flat out. I can change direction. So it's now running the other way. I can change direction on the fly. No squeaks or worries about it at all with that. And obviously my minimum is right down to hardly moving. I can't see me needing any slower than that. I can engage carriage. As you can see, the carriage is off and away. So let's give it a try. I've just got to do a couple of cuts on this bit of brass for a project I'm doing here. So just treat it like a normal lead screw now. You can adjust the feed rate on the fly, which is why I went for the original one, but the same with this one. And you just disengage and engage the feed as you normally would with the lathe running. The only difference is that this will keep running when the lathe is stopped. I could fit a relay in, you know, that knocks off the 24 volt, something like that, or kills the enable, basically. So basically switches it off when you switch the lathe off. I could do that. I could put limit switches either end so that it can't go beyond its extremities. Thing is, the extremities change all the time depending on what you're machining. So yeah, I just use the engage and disengage. I wouldn't leave the lathe unattended, you know, with the feed still on and stop the truck. Why would you ever do that? So yeah, for my purposes, I don't think I'm going to need limit switches on it. I think I'm absolutely fine. So start the lathe up, start the feed up. And now we can't hear the feed motor. We used to be able to hear it howling away. Let's just turn the feed rate down. I'll engage it. This is going to be way too slow, so let me turn it up. There we are, nice fine feed on there. And obviously I can bring it in a bit. Let me turn it up a bit and turn it down. Yeah, it's great. Works a treat. So I'm thinking whether to guard it or not. I mean, I'm not often. I mean, there's probably worst cases brass, where I'm basically spraying swarf that would get anywhere near the end of the motor where the feed is. But yeah, I'm not going to be putting my hands in there. I can still turn it now with it switched off. Easy piece. So yeah, if I want to use it like I did before, where I can hand wind, I can still do that. Yeah, it works well for me. Well, there we are, guys. I think that's about enough for this one. So sporting the Christmas jumper. As I'm recording this, it's the 23rd of December, so we're getting very near Christmas. So whatever a religion or belief is, I mean, it doesn't matter to me, but it is a season of goodwill to everybody. And if you don't believe in all of that, at least you get a bit of time off work and all the rest of it, which I certainly have as well. So it's going to be nice to have a bit of time away from work. Might even be able to get a bit of time in the shed. So as I'm recording this, that's 2 projects complete. The Stewart model's engine is now complete with all its details, everything done. There's a few little things like a case and what have you that I want to do for it, you know, just to keep it safe. And obviously the electrical parts on the lathe are done as well. Now it's got a stepper motor instead of that noisy motor, and I'm sure you notice the difference in sound. So anyway, with it being Christmas, let's get into the spirit of things. Oh, take off the normal glasses and put on the proper Christmas pudding glasses. And I just want to say a great big thank you at the end of this year. I'm sure it's been tough for a lot of people 2021 was a tough year with COVID and all the rest, much as 2020 was. So a big thank you to all my subscribers for clicking that subscribe button. If you haven't, click it. And to just viewers as well. And I wish you all a very Merry Christmas. And I'm going to leave you with a clip of the Stewart Models engine running. Merry Christmas, everybody. Cheers. Ho, ho, ho.